Okay, we have an example here where our a value is a -1. So we are going to need to factor out that -1 when we're completing the square. With the a value being less than 0, we know that our parabola is going to open down and we are going to have a maximum value. So I'm going to come over here. I'm going to change my f of x to a y. And I have y equals, I'm going to factor the -1 out of the variable terms, giving me x squared plus 5x. I'm going to leave room to complete the square. And then I've got the constant on the outside of the parentheses. Now half of 5 is 5/2. If I take 5/2 and square it, I get 25/4. This 25/4 is subject to being multiplied by -1 because of the distributive property. Therefore, what we really did was we applied a -25/4 when we completed the square. So we have to undo that by adding 25/4. So we can't just simply look at the number or the fraction or the value that's on that line inside the parentheses. We have to make sure that we apply any factors on the outside of the parentheses to that number so that we can undo that entire product. So this -25/4 is a product, and we have to undo that product by adding 25/4. So I'm going to write this in vertex form. -1 times x plus, this is a positive because our linear term inside the parentheses was positive, x plus 5/2, this 5/2 just comes down and falls right in there, quantity squared, and then I have -3/1 plus 25/4. I'm going to get a common denominator, so I have -12/4 plus 25/4, which is 13/4. So 5/2 is 2.5. 13/4 is 3.25. So our vertex, even though I'm going to put -5/2, I know that I'm going to go left 2.5 when I actually go to plot the vertex, comma 13/4. And when I plot the y value of the vertex, I know I'm going to go up 3.25. The axis of symmetry is x equals -5/2. I'm going to plot those two values right now. So I'm going to go left 2.5 and then up 3.25. So there's our vertex right there. I'm going to use a highlighter to draw my axis of symmetry that goes right through the vertex. We talked about a being a negative value, therefore we have a maximum. And that maximum is equal to 13/4. The input for the max is -5/2. And then we have our x-intercept and our y-intercept. Our y-intercept is pretty simple. Our y-intercept, we go right back to the original standard form of the equation and we put a 0 in for x. So we get a -3 for our y-intercept. I'm going to plot that right now, 0, -3, and I'm going to reflect it over the axis of symmetry. And now I just need my x-intercepts for some accuracy. So my x-intercept, you put a 0 in for y, and then we are going to solve. So I'm going to subtract 13/4, and then I'll be able to multiply, or you can think of it as division, both sides by a negative. So I have 13/4 equals x plus 5/2 quantity squared. We'll square root both sides, and I get plus or minus the square root of 13 over 2, because the square root of 4 is 2, is equal to x plus 5 over 2. When I subtract 5 halves from both sides, I get negative 5 halves plus or minus the square root of 13 over 2. I'm going to go over to my calculator, and I'm going to put this into my calculator. Now, exact x-intercepts would look like this. Negative 5 over 2 plus the square root of 13 over 2, comma 0, and negative 5 over 2 minus the square root of 13 over 2, comma 0. Those would be exact intercepts, but that doesn't really help me plot them. I could do this with a little bit of work, which I have done, but I'm going to put this into my calculator right now. And I get negative 0.7. So negative 0.7-ish, comma 0. That's when I add. So that's this one right here. And when I subtract, I'm going to do the subtraction, I get negative 4.3-ish. So I'm going to plot those two intercepts, negative 0.7-ish. Make the dot big enough, nobody knows. Negative 4.3, 1, 2, 3, 4.3-ish. And then I'm going to draw my parabola opening down, and I've got everything I need. Now, we could put some more points in there if we want to get even more accuracy, but I think this is a pretty good job. I just like to extend my parabola so that it exits the grid. It looks a little bit nicer that way. Now, before we go on to our next example, I just want to make sure that we can identify the domain and the range. The domain is negative infinity to positive infinity, and the range goes from negative infinity all the way up to that maximum value of 3.25, which is 13/4. And it includes that 13/4. Okay, let's try on the last problem that we did. Our domain goes from negative infinity to positive infinity, and our range starts at negative infinity. It doesn't really start at negative infinity, but that's the lowest value, even though infinities aren't technically a value. Negative infinity all the way up to this 2 value. So negative infinity all the way up to 2 with a bracket. And on the first example, our domain is still negative infinity to positive infinity, and the range this time has a minimum value, so it starts at positive 2 and it goes all the way up to positive infinity. So 2 is included, so 2 is a bracket, all the way to positive infinity. So there's our domain and range for each of the 3 problems. Now this fourth problem is going to ask us to actually write the quadratic function. So if you'd like to try and do this, you're more than welcome to try. Put together, kind of think about your vertex form and the information that they're giving you. Otherwise, in the next video, I'm going to explain it.